All right, we're going to get started. I have a few things to go over before going into the lecture content proper. First up is an announcement that Student Accessibility Services needs a volunteer note taker for this class. So if you feel like volunteering, this is a good opportunity to, yes? It could be useful for them to get notes of things that I talk about in the class. And like, if you're asking that, you may as well say, why does anyone take notes ever? I post my annotations, but there might also be things that I mention but don't write down that are valuable. So this is still useful. So yeah, if you want to volunteer, anyone can log on to this portal and upload your notes. They could be any style, written or typed. It takes about an extra 15 minutes weekly, and it just helps create a more inclusive environment for students with disabilities that may not be able to take notes themselves. Next up is some stuff about quiz solutions. Heard the class get real quiet there. A few students have asked if I can release them, and I've sort of waffled like, oh, I don't know, if someone else in the department might get mad at me. I talked it over. The higher-ups are pretty mean about copyright and stuff, but, oh wait, I shouldn't say but yet. Because of this copyright stuff, I wouldn't be able to release the quiz solutions. The explanation I was given is that they are going to immediately be uploaded to Chegg or Course Hero or whatever, and then used to train generative AI, and then the university doesn't like that. But I can still talk about them face-to-face and during class. So I'm going to cut off the recording, and then of course bring it back once I'm done going over the quiz solutions. I'm going to cut off the recording and show you all the solutions for the quizzes so far. And then I'll plan to make a weekly routine of going over quiz solutions after that quiz. So let's use the last 10 minutes or so to get a preview of next week's content. We're basically going to spend next week looking at a few examples of specific data structures. You learned about arrays when you just started programming. You probably learned about linked lists pretty soon after, but you got a good review from earlier this week. Next up is the stack and the queue. And later on next week, we're going to talk about dictionaries or hash tables, which can be used to implement tables. A stack and a queue is an ordered sequence of homogeneous data whose size is dynamic. Homogeneous roughly means same shape. In practical terms, it means the data is of one type. The key difference between a stack and a queue is how they're sorted, how the entries are sorted, and in what order you can access them. So in a stack, new data can only be added at the top, and new data can only be removed from the top. And I'm not sure how well this will work based on how far you are from me, but I brought a stack of books to use as a prop. So I can put a new book down on the top of the stack, and I can remove one from the top of the stack. Once they're all stacked, I can't access anything that isn't on the top, I can only look at the top and put it back, or look at the top and remove it. I don't think this is going to work with the book metaphor, but in a queue, it's sort of the opposite. New data can be added from the back of the queue and removed from the front. I'm going to attempt to do this with the books. Okay, good so far. So an insert would be called enqueuing an object. So I insert objects at the back. And then when I want to take an object out of the queue, this is the important part. I take them from the front of the queue. Last in, last out. A better metaphor than books, even though books were a great metaphor for the stack, is a line at a grocery store or like any situation where people queue up. You join at the back of the line, you stay in place because you're nice, and then the first person to leave the line is the one who joined the least recently. Last in, last out. Actually, it should be last in first. There might be a mistake on here, but I don't feel like thinking about it that hard. It's Friday. I'm going to correct it in the version of the slides that are posted on the website if it's indeed wrong. Like any ADT, the stack is defined like loosely by the type of data that it stores. Really, it could store any type of object, but more specifically by the operations that it allows you to do on those objects. Oh, also, I can't fully justify this now, as you haven't seen any examples of stack usage. But the fact that there's a limited range of operations you can do on a stack or a queue can be really useful. There are many situations where you have some data and the only type of accesses you ever do are like pushing, popping, etc. And because of that, when your program inevitably breaks, you can rule out any bugs that have to do with accessing elements that are in the middle of the stack, as long as you trust your stack ADT implementation. And if you're in the real world using the built-in Java data structures for these, you should trust them. You'll be able to rule out bugs that have to do with the data structure not working as intended. And that's why they work as intended by doing a small subset of the things that arrays and linked lists can do. So let's go through operations. Push adds a new entry to the top. I'm going to pre-populate my stack. I just pushed an entry to the top of it. Pop removes the top entry from the stack and returns it. So it's no longer part of the ADT or its implementation, and you can read it and do operations on it. Top also returns the top entry, but it does not remove it from the stack. Nothing about the data contained in the stack changes. Is empty checks whether the stack is empty. It's not. And the constructor creates a new and empty stack. And then This is sort of blurring the lines between ADT and implementation, ADT and data structure. But your stack may or may not have a space limit. If you're implementing it using an array, which might have advantages in terms of fast memory access, you'll probably have a space limit, and then it'll be useful to have an isFull operation. And then you would call, or in your implementation, you would call isFull as part of the push method and prevent push from working if it has. This is my 3-book stack. It can only hold up to 3 books. So if isEmpty would prevent me from adding a 4th book to it. Of course, if you're using a linked list, the big advantage of that is that it allocates memory dynamically. The only space limits are the ones that exist in your operating system and however it manages RAM. But then you lose some advantages from arrays. It's all trade-offs, all the way down. This is almost certainly going to be a quiz question next week. This or the Q equivalent. We have specific notation for what a stack looks like on paper. This square bracket is the bottom of the stack, and the angle bracket is the top of the stack. You could think of popped elements going this way in the direction that the angle bracket is pointing. So this means a common question for stack comprehension is to give a sequence of operations and asking you to state the return value, if applicable, and draw the stack at every stage. Whew. This example is pretty gnarly. I'm not going to go into this today, but as a preview of next week, bracket matching is an important concept in compilers and code editors, just to make sure that the brackets are arranged correctly. Every opening bracket has a corresponding closing bracket. Turns out stacks are very useful for this, and you'll see why next week. All right, have a good weekend.